Welcome. This is the part 2 from a series of videos regarding fatigue analysis in frequency domain. In the current video, the fatigue life of two different models will be calculated. In the first section of the video, combination of random and deterministic loading will be used. The second section is regarding multi-correlated loadings. First, use as input the XML of the subframe from part 1 video, which has already an analysis. We are going to perform a new analysis of the same model. Go to Task 1 and click Add Analysis. The new Analysis 2 is appended under Task 1, below the already existing analysis. Moving forward, go to the Analysis Configurator window, so as to set the necessary analysis parameters. The aim here is to perform a stress-based fatigue analysis, using the uniaxial method in the frequency domain. Generally, this process is linear and Gaussian. The input results are of type FRF, which stands for frequency response function, and is going to be combined with the accelerations PSD to finally get the stress PSD through a random response analysis. Choose Dirlik algorithm to estimate the stress PDF, probability density function, and finally calculate the damage via Miner's rule. Moreover, no mean stress correction will be used for this analysis, and the evaluation will be for the Siegelman-von Mises on the element corner for both top and bottom shell layers. The next important step is the definition of the loads through the loads database. The user can either manually define a load or import a file with the loading. The loads used in the previous analysis are also displayed. In the present session, manually created loads will be used. Click on the button Create a new load and select the option PSD. Define manually the desired values. An overview of the loading is displayed on the plot. Then, click again on the button Create a new load and select the option Sine Sweep. Define the desired values and see an overview of the loading on the plot. Switch to Assign Loads. Select the box of Event 1, Radom, and click on the PSD button. Combine the subcase 1 with the PSD loading. Then, select the box of Event 1, Deterministic, and click on the Deterministic button. Combine the subcase 1 with the respective deterministic load. Subsequently, the current analysis has one event in which a random and a deterministic load are applied. Deterministic load excites specific frequencies and is combined with the random loading. Finally, the user can optionally specify an output path in order to save the MetaDB with the results that will be output. Move to the field Select Entities to calculate. The option All will be chosen, where all entities that are assigned a fatigue material participate in the analysis. Moreover, to filter the area where the calculations take place, the user can use the option Filter Entities. For the current analysis, choose RMS stress over 50% of max RMS stress and run the fatigue analysis. With this filter, the analysis will run only on the elements which have a value of RMS over 50% of max RMS stress. Once the analysis is completed, results can be displayed through the dedicated plots of fatigue. Run also the first analysis to be able to access the results per analysis. The user can switch the respective fields to display the results from the desired analysis. Through fatigue analysis type, results such as damage, life in seconds, log of damage, log of life, and spectral moments can be demonstrated. Especially for the second analysis, where there are combined a random PSD and a deterministic load, the results are accessed for each frequency of sine sweep. Furthermore, it is easy to define annotation on worst element with detailed information. What's more, press the Post tab to access more plots. Choose the Events plot for an overview of the damage and life of all events as bar charts, as well as a total life and damage bar. All results are accessed for both of the analyses. Through the option to select the event, the sub-events are visible. 10 sine wave sub-events are showed as determined by the number of sine bands when the sine sweep was defined. All 2D plots have a direct interaction with the model. So, by modifying the parameters, the plots are updated. For example, more than one element can be chosen by the user with the option pick. Directly the desired results are displayed on the selected plot. Continuing with importing a different model, we are going to study the fatigue life of a few selected subframe and rail components of a vehicle under loading in the Z direction, coming from a certain road pattern. The loading is applied in the 4 spring damper mounts of the vehicle in the Z direction. The input signals act simultaneously and are checked for cross-correlation during the signal processing, thus resulting to both PSD and CSD inputs in terms of displacement. The stress FRFs are given as 4 different subcases under the uniaxial loading at each spring damper mount. Create a new task and load the new model. For this action there are 2 ways. The user can load either the geometry or the results file. For this case, the geometry file is loaded. The next step is to set up the material for the model. Access the material database of Task 2 in order to select materials for the current session. Select from the internal database Steel 1005 and Steel 1020. Use the arrow to place them to the session materials list. Switch to Assign Materials. Assign materials to MIDs. For the second MID, set Steel 1005 and for the fifth MID, set Steel 1020. Moving forward, go to the Analysis Configurator window, so as to set the necessary analysis parameters. The aim here is to perform a stress-based fatigue analysis, using the uniaxial method in the frequency domain. Generally this process is linear and Gaussian. The input results are of type FRF, which stands for Frequency Response Function, and is going to be combined with the accelerations PSD to finally get the stress PSD through a random response analysis. Choose Dirlik algorithm to estimate the stress PDF, probability density function, and finally calculate the damage via Miner's rule. Moreover, no mean stress correction will be used here, and the evaluation will be for the Siegelman-von Mises on the element centroid for both top and bottom shell layers. The next important step is the definition of the loads through the loads database. Click on the button Import a new load. Load the necessary files that include the PSD loads. Switch to Assign Loads. Select the box of Event 1, Random, and click on the button Multi-PSD. Load from the results file the stress FRF. Once the file is scanned, the correlation matrix with the detected subcases will appear. Choose the option to import a correlation matrix and load the desired file. The correlation matrix is loaded. Otherwise, the user can manually fill the table. Subsequently, the scenario has one event. Finally, the user can optionally specify an output path in order to save the MetaDB with the results that will be output. Move to the field Select Entities to calculate. In order to get results only on certain elements, these elements have been assigned to a set, called output set, during pre-processing of the Nastran model. So in the Entities to Calculate field, choose the option Manual from Sets and select the output set. Once the analysis is completed, results regarding the fatigue life, random response, and the input results can be displayed through the dedicated plots of fatigue. In the Plot Properties area, through Fatigue Analysis Type, results such as damage, life in seconds, log of damage, log of life and spectral moments can be demonstrated. Through the sets list you can isolate the area of interest. Choose the desired set and click on the option Show Only. Furthermore, it is easy to define annotation on worst element with detailed information. There is also functionality to post-process PSD information. Switch to the Post tab and create a new PSD item or choose the events plot for an overview of the damage and life of all events as bar charts. All 2D plots have a direct interaction with the model. So, by modifying the parameters, the plots are updated. For example, more than one element can be chosen by the user with the option Pick. Directly the desired results are displayed on the selected plot.